right, guys, we're going to start. Our next speaker is Patricio Calderon. He is an application security engineer at Parity Tech, and today, together, we'll explore the Polkadot Security Hub. So, Patricio, take it away.
Thank you. Greetings, everyone. Thank you for coming to this session. Today, the main objective is to explore the Polkadot Security Hub and to try to get to a point of a discussion between everyone that is present about how we can improve all the security practices in the Polkadot ecosystem. I am Patricio Calderon, application security engineer at Parity Technologies, where I am in charge of auditing and managing all security about the projects that we develop. The format of today is a little different than a normal talk. The goal is that we have more as a discussion about different security topics in the format of a Barcamp, with the goal to collect feedback from all the ecosystem. It doesn't matter if you are just starting or you already have experience, to come with the right resources and tools to get to an nearly optimal security in the ecosystem. Before starting, I would like to get to know a little of who is present, so I can orientate more into something that is more useful for the people present here. So if you can put your hand up if you are building a parachain or working in a parachain project. Solo chain? OK, there is one. And anyone building in Rust or starting in Rust also can work? OK, OK. This talk is mainly oriented to application security. So we are putting aside topics of DevOps or other type of more like people security. We are not going to talk about IT or stuff more into that level, but more into the technical side of Polkadot, in the coding part, in the Rust side. And to start, the main question and why I came up with all this talk and all these resources is because a lot of people in the ecosystem, maybe it's their first time building a production-grade system, and they don't have really well experience into security. And security is not something that you can improvise. Normally, you need to have certain order, and you need to take specific strategies. As I have experience in Web2 security, I tried to bring this to Web3 security. And I came with a modified version of NIST. NIST is a framework used broadly in the Web2 world to tackle security in big systems. This strategy is composed of 5 steps. Here we have the 3 most important, from my perspective, that are the first ones: identify, protect, and detect. How you can use these steps, you need to go one by one and analyzing in order when you are starting a new project. The first step is identify. Here I'm going to go quickly into this step, and after we are going to go more in detail of what it means, each one of these things. In identify, you start by determining the first thing that you need to do when you are creating a project, the chain design and requirements, or project specification. As you can see, a good example is Jam. They are already starting with the specification, that is the gray paper, and after they will start with the implementation. Why is better in this approach? Because in that way, you avoid having misunderstanding between the developers and some lack of coherence that can lead to serious problems. After chain design and project specification, you need to try to do a threat model. This is a step that the majority of projects in blockchain, not only in Polkadot, but in every blockchain, they skip because they think that it's not so relevant. But as we're going to see later, this can also help you save a lot of time when bad things happen. Later, we have to go to the second step, that is protect. And in Protect, you need to become more aware of the common risks, the internal risks, and the external risks that you can have in your system. So if you are developing a parachain or a solo chain, you are probably using Polkadot SDK and Substrate. And here we made a top 10 of the most common vulnerabilities that I will show later, where you can learn in detail with examples what are these common problems. And you can also have a game where you can actually exploit this in a safe environment and learn how they work in practice. You also have internal risks that you can tackle with more development tools, like integration testing, end-to-end testing, and different type of testing tools. External risks that are your dependencies. All the supply chain of your project is a risk, and you need to be aware of how to handle it correctly. Later, we go to the tech step, where you need to monitor everything in the ecosystem and in your system. With this, you can use telemetry, metrics, trace to monitor your own ecosystem, and you can use disclosures that I will show in the Polkadot Security Hub to know what are the new vulnerabilities that have just come out to the public. And you can also use bug bounties to enhance even more the security of your system. After you have understood these first 3 steps that are the most relevant when you're starting, you also need to be prepared for the last 2 steps, respond and recover. And here I will not go too much in detail, as this will take a long time and is not the aim of this talk. But here you have things like communication protocols, incident response plans in case something bad happens, mitigation strategies, different other type of things. Normally, you will not have to rely into these things if everything goes correctly, but as the blockchain world is Wild West, you need to be prepared for this type of things. The strategy that I have here, I put it in a ScaliDAO that you can access in the Polkadot Security Hub. Polkadot Security Hub is this website that you can access with this link. We don't have a great domain yet, but soon we're going to have a better domain. And here you can access to all the things that I just mentioned, specifically the first 3 steps, and you can find all these resources that I am mentioning in detail, so you don't have to take notes now. And if you go to the blog, that is the place where we are putting all the latest things, you can find this blog post that contains this ScaliDAO that I just showed, and the Google Slides. Let me come back to here. So the third point that I just mentioned was chain design and requirements. When you want to design a chain design, you will need to get some examples, because probably you have never seen a specification if you're just starting, and you will want to have something more related to Polkadot. And for this, you can go here, identify, and here you can find specifications. In this case, for now, there is just 2, but this is an open source project, so every Polkadot project could add their own specification to this website so other people can see it. After this, you will also need to have some examples of what is like a threat model. And for this case, I put here a DFD of like it's not so visible. Yeah. A DFD is a data flow diagram that explains how the data moves in your application. This is the first step when you're building a threat model, and it lets you understand what are your assets, how these assets are moving around, and what are the points where they can be attacked. This DFD comes from a threat model that you can also find in Polkadot Security Hub. And here you have a detailed version of this where it explains all the risks, all the scope of the project, the participants, the DFD that I just showed. Here you can see how the things are placed in this project, actors, and different protocol layers. The idea here is to introduce to these examples so you can use it for your own project if you are developing something. And the question that maybe will come up here is like, why even prepare a project specification, or why invest time into a threat model? The first question is mainly developers. If you have a big project, normally when you start developing a parachain, it's a big investment, so you will probably contract or get to a team with many developers, and these probably come from different backgrounds, from different worlds, and they will not everyone understand your ideas in words as you want them to be. And one of the main issues in blockchain, as I work a long time as a security researcher, is business logic issues. This happens when the specification of a project is not clear, and the developers code something that doesn't fit with what is expected. So why prepare a project specification? Because in this way, you don't have to rely in just words, in meetings or something like that, and you have a clear point that will help the developers to implement what you want. And why invest into a threat model? A threat model, normally, if you want to see it from a business perspective, will be something like an audit. You will have to go to a security provider, and they will provide this as a service. Why a threat model is relevant? Because if you just let the developers or your company to depend into the documentation, for example, you go to any blockchain project and you're going to find the documentation where they explain you how to use the system. Normally, it's not really well explained, and it doesn't explain what are the most critical things of your project. And when you're handling with audits, bug bounties, or incidents, you need to understand what is the severity of the issue. For example, if you have a bug bounty and someone came and say, I found a critical, you need to be sure that he's actually finding a critical and not something that is maybe a minor finding, because otherwise you will lose a lot of time trying to fix that issue, and it ends up being nothing. And maybe you're going to even lose money because you're going to give a huge amount of money to someone that doesn't really deserve it. Or it can also happen in the other way. Someone can come and think that he found a minor issue, but it's actually a critical, and you need to fix it as soon as possible. This can happen in bug bounties, but can also happen in incidents. Let's say one of the developers found a bug while it was developing. And if you have a good threat model, you will be able to understand quickly if that incident corresponds, if that bug corresponds to like a security issue. Here, well, put the link, but I'm not sure if it was there. But better I will ask, is anyone has any question about these topics? Or even if it's just a starting question, anything will be helpful. Well, there is more place to put questions after, so I will go step by step. And
what do you think about the role of fuzzers
in
evaluating security?
So, I like your question, and let me just answer your question in the next step, because in the next step, protect, I talk about fuzzers, actually. So let's put it here. What about? Okay, I will answer it there. So, another question about the previous topic? Okay, let's jump into this. So the second step, as I mentioned at the beginning, is protect. And in protect, you try to tackle the main risk that can your project front. Let's start with common risk. So common risks are, as the name says, things that have already happened, things that developers have found. If you study like previous audit, you can see that these things comes quite often. And these are described in the Polkadot totem that you can find here, where there is a series of documentation of each one of these issues. You can find, for example, insufficient benchmarking, that is the #1 issue in Polkadot when you are developing in Substrate. And this happens when you, for example, develop extrinsic, like a call, and it's not well benchmarked, and someone can use that to DDoS your application. I will not go one by one because there are too many, but you can access to this website and read in detail what are these. And you can find, for example, examples here of how they work and how they could be exploited. There is also Polkadot base that is just everything that is not in the top 10. We are just putting it there because we are constantly changing this. And to not having to delete something, we just move it here. And the other resource that you can find here to tackle common risk is the Parathread game. That is a game that you can find in GitHub that show you how to exploit this thing, and it has clear instruction of, like, here you need to write this is a transaction to exploit in this way and stuff like that. Okay, so those are the common risks. And now let's go to internal risk. And here we have control code quality tools, or QA tools. And this one are better explained here in the security tools and testing infrastructure. Here you can find a series of tools that are up to date and usable nowadays that you can use to tackle different part of your project. I will go quickly to each one of them. Supply chain management is what the name say, is to handle issues that can come from your supply chain. Here we have PSVM, that is a tool that you can use to be sure that you're using the latest version of Polkadot SDK or a previous version, ensuring that all the crates have the correct version. You have also cargo vet, that is to track audits, and cargo audit, that is to detect common vulnerabilities in Rust crates from the Rust ecosystem. You have static analyzers like Clippy and Delete. We still don't have a great static analyzer for Substrate, but these two will tackle a broad amount of like Rust issues. For unit testing, you can have XCM simulator that allow you to run XCM directly in your chain, quickly and in a safe environment, and try and next test, that is just a different way to run this test in a faster way. For integration testing, we have things like XCM emulator that is not the same as simulator, because in simulator you can only run XCM in one chain, but in emulator you can send to other chain and do cross-chain communication. And you have something that is quite useful when you are dealing with migrations, that is try runtime, that will allow you to execute a block in the future about certain upgrade that you are doing in your chain. Next, we have fuzzing. That is where the question here come up. Fuzzing is actually really useful in the case of Substrate, and you will see that in a broad amount of projects, developers will tend to opt for fuzzing when there is not a good static analyzer. And Fuzzer is actually well developed in Polkadot, thanks to a collaboration with SR Labs, where they came up with the Substrate runtime fuzzer. This is a fuzzer that you can connect, well, you can integrate with your runtime, and it will fuzz your whole runtime. So every pallet, every transaction, extrinsic that you have there, to try to find bugs or different type of things. If you don't know, like a runtime or a extrinsic should never panic. If you're, for example, there is you are accessing to an index that is incorrect into an array or something like that, and it throws a panic, your whole chain will go down. So this tool is actually useful to find those type of things, especially when you're using XCM. A common issue that you can find also in the top 10 is that when someone sends XCM and this XCM executes an extrinsic that causes a panic, now the chain cannot recover because parachains are forced to execute XCM, and because that XCM is in the queue, now it will not be able to recover so easily. For this, you can use Substrate runtime fuzzer. You can find here. There is currently running every day these fuzzers with the Polkadot runtime, Asset Hub, Bridge Hub, and the main runtimes of Polkadot. We have configured them in virtual machines in the cloud, and they are constantly being put to test. Yeah, here you can find, and there is instruction of how to use it and how to integrate it with your parachain runtime. After this, we have end-to-end testing. Here you have the amazing tool that is ZombieNet SDK. This tool allows you to execute test scenarios that will be almost as if they were in real life. It will actually run spawn nodes in your computer or in your server, and it will execute things against them. So this allows you to test things like consensus or more complicated things that you cannot test with integration testing. And other tool that is an alternative to ZombieNet is Shoptick. Shoptick allows you to do the same, but using JavaScript. With this, you can even go to the point of executing real-time network state. So let's say you want to test, you have a test case, but it doesn't work with ZombieNet, it doesn't work with integration, because you need to have the latest state. Well, for this, you can use Softies, developed by Akala, that allow you to test with the real network state. And after, you have testnets and the canary network, that is Kusama. And just putting this as the last resource that you can use. Yes.
Can you go over what the difference between using chopsticks would be over ZombieNet?
Well, one of the first difference is, well, ZombieNet, you write it in like a JML. So it's like they created their own language that is like human language to write this test. So the first thing is the syntax. The syntax is different in each one of these. The first one is like human language. The second one is Rust. And the third one is JavaScript. Cheftics even can run in the browser. So this is a huge advantage, and it has like a real network state that is not yet completely built into ZombieNet. In ZombieNet, you can execute against a snapshot, but it's not automatized in such a way that you can just say, let's run it in the last state, and it will run in the last state. You need to download the snapshot from the state you want.
So in a nutshell, chopsticks is real network state, current, versus ZombieNet. I can use different snapshots of different network states at different times.
Yeah. I mean, you could also use chopsticks to run in previous state. I was just mentioning the main difference that have chopsticks in comparison to the other ones. But with ZombieNet, you could also run to any state that you want. It will just require a little more of like DevOps.
Got it. ZombieNet is a little bit more, got more stuff packed into it, basically.
It has more features, but at the same time, it's a little more complicated. But if you want to write things in, let's say you are writing your palettes, you have all your structures, and you don't want to use other language, the preferable option for developers will be Zombie.NET SDK that is currently being integrated into Polkadot SDK to the runtimes. Why? Because it can reuse the same types that you already have, all the structures, because everything is in Rust.
Thank you.
Okay, so the other one was testnet, Rococo, Western Paseo, and Canary Network, like Kusama. Here there is a table, because there is a lot of tools and things, and maybe you will think, like, when should I use this? Well, coming back to the top 10, if you want to tackle one of these things from the top 10, you can go to this table that will allow you to see what are the tools that you could potentially use and what are the recommended tools that you can use. For example, for reachable panics, the clear option is fuzzing. But you could also use all the other tools. For outdated craze, supply chain management, you can read more in detail in the website. So this is internal risk, and now let's move to external risk. External risk is a topic that a lot of blockchain projects normally don't care about, especially people coming from front-end development, because in front-end, you just put npm install, and you have like hundreds of dependencies that you will never be able to understand what they do. But in Rust, there is a more security approach to dependencies, and there is really good tools that you can use. For Polkadot, you have PSVM that will allow you to set the version of your dependencies. And from Rust specific, you have cargo audit that is mainly used by RustSec and by big companies like Google, Mozilla, and other big tech companies. In the same way, you have CargoVet, and what is the difference between these two is that CargoVet is mainly to say, I have this dependency, and this dependency is audited, and audited by who. The great thing is that this works as a linked repositories. So let's say you trust Mozilla, you can add Mozilla in your repository, and now you will see all your dependencies that were audited by Mozilla or people that Mozilla trusts. The same thing with Google and other big tech companies that are big into this tool. Well, CargoVec is actually developed by Mozilla. And you have also Cargo Audit, where you can find specifically, for example, here we have an example, which version of this crate has a vulnerability. This is very easy to use. You can, if you have a Raspberry, you can just go and put Cargo Audit, and it will automatically tell you which dependency has issues and to which version you should move. So the questions that I put here, just to start, are what should I protect from? Well, the main things that you should protect are common risks, because these are things that everyone can know and will be the first thing that someone will try to exploit in your system. The second one are internal risks. Normally, you can tackle this with developing tooling. So be sure to always have tests, and not just tests that go to try to catch the happy path, but also like more complicated paths. And external risks by having good DevOps about your dependencies. What are the most common high severity vulnerabilities? Well, the most common ones are always business logic, because are the ones that no tool will be able to catch, and are the ones that you need to be more careful with, and are the main ones that will detect if you pay for an audit or you have a bug bounty. So well, this what fuzzers we already answered. Anyone has another question about tooling, or if you need some tooling for your project or something like that? You have one? No problem.
How could you leverage fuzzers in order to check some maybe security properties related to business logic? I mean, these problems you mentioned as the most high severity vulnerabilities. Maybe we have some kind of framework to describe this or something like this.
Oh yeah. So you can leverage fuzzers by mixing with symbolic execution or like formal verification in such a way that you can put things like I forgot the name, but you can put things like ensure, and that will try to ensure in your code if something reach a certain property. Let's say you have balance and you need to ensure that this balance will never go under 0. You can maybe put this thing and assert that will only execute in testing and not in production. And you can fuzz your system in testing. And in that way, you can enhance these properties, like property testing. That was the word that I was trying to find. And you can combine with business logic. Why? Because in business logic, you normally have conditions that you want to achieve. You want that the balance in your account is never under a certain amount, or you want that there is always a specific amount of users. And this, you can write it as asserts that will only execute in testing, and in this way, you can fast to find when this crash.
So you basically modify the source code itself, introducing some kind of debug asserts that
Yes.
You can leverage only in the fuzzers execution.
Yeah, exactly, exactly. That's the main way that you can enhance fuzzers. Anyone more? Okay. Let's move to the next step. So, the next step is the tech. In the tech, you have to take more an approach of monitoring and look into what others are doing. The first thing that you will probably think when you are trying to get to this step is how do you actually ensure the security of your system. And to do this, you need to rely into security audits that are probably a famous concept into Web3 or Web3 audits. And if you have a project, you will probably come up to the moment of saying, okay, I need to audit my code. How should I do this? And to run an audit, you first need to define the scope of this audit. After, you need to define the dates. What are the dates that you want to get this audit delivered? You have a release date, and you need to do this before. And normally, you need to consider that auditors are like developers. They will also take time to do something. And you will need to find a provider, and after, you will need to execute. And if you are new in Polkadot ecosystem, you will start thinking like, okay, I cannot go to the same auditors that other ecosystems are using, or maybe I can, but I'm not sure. So for this, we added a new resource to the Polkadot Security Hub, where you can find all the previous audits that have been ever done in Polkadot ecosystem. These are sorted by dates. Well, probably it's missing some of the audits that have passed in the previous months. But here you can see the firm. For example, SR Labs is a common firm that you can find in Polkadot ecosystem that works directly with Parity, but also works with other parachains. And you can find which project was audited, and you can find the report. So you don't have to rely in someone telling you, oh, this auditing firm is good or this auditing firm is bad. You can directly go to the report and see what they did, how they did it, how they take an approach into securities, and after you can contact them. Here we have things like SR Labs, OAK Security, Code for Arena, Celic, runtime verification. So feel free to come here if you want to start your journey into discovering a security provider. Other topic you need to take into consideration is monitoring your system. This is more like DevOps side of security, but you should also be aware that this is quite relevant when you are launching to production. And for this, you can use tools like telemetry, metrics by using Prometheus, and Grafana. And you can put traces in your code to ensure that everything gets registered. So if by any chance an incident happens, you can quickly detect what is the root cause of this, and in this way you can tackle it faster. Another step is monitoring. Oh, some mistake here. Monitoring the environment. And for this, you can use disclosures. This is a resource that is here available. And hopefully will charge. Well, it's not charging, but normally you will see here a series of disclosures that have been published by Parity and other parachains. And yeah, not sure why it's not charging. Let me go here. Yeah, so this is what you will see. Now I'm not sure why it's not charging, but you can see the title of the disclosure, and here when you put more details, you will see the scope, and you can check quickly if your system have this issue. Normally, you will not see only like crates that are vulnerable. So let's say it will not come and say, okay, pallet balance doesn't work. It will say, for example, pallet balance doesn't work if you use it in this way. So, and it's going to explain in detail how you can mitigate this issue. So if you are using pallet balance, for example, you can change the configuration to ensure you are not using it in an incorrect way. Let me go back here. So the last point that I will mention in the tech step is book bounties. About book bounties, we put here also an aggregator of all the book bounties that we have for now. The first one is Polkadot and Kusama. Here you can find the main book bounty that is run by Parity, and that covers things like Polkadot SDK, runtimes, production infrastructure, and Polkadot JS. So if you have like a project, a parachain, a solo chain, or any project that requires to have a book bounty, you can come and find more details here, and you can see how this is settled, or you can even contact us, and we can help you to like organize your book bounty in such a way that makes sense. When you want to run a book bounty, as I will put here in the questions, you will also need to follow a similar approach as running an audit. You will need to first set up the scope. You will need to set up the bounty, and you will need to set up the curators. And setting the curator is not such a simple step, because here you will come with like providers of a book bounty, like Immunify or other platforms that will offer you to, instead of you having to run your own book bounty, they can run it for you, but at a price. And here you will have to decide if it's worth it to go with them, or it's better if I run it ourselves. In the case of Parity and Polkadot, we are running it ourselves, and you can find here, and you can also find here who are the curators. And we have a similar book bounty, but for the Polkadot Kusama bridge. these are not the same, but they were kind of similar. What this involves is the Polkadot Parity Bridge Common, Polkadot SDK Bridge, and the runtimes of Polkadot SDK and the fellowship. So the idea of having all this here is that you can use it as an example to run your own bug bounty. Okay, so I already replied these 2 questions. And does anyone has questions about all these topics that you can see here, about security audits, system, declosures, bug bounties?
Yeah, I'm curious, like historically, what have been the most interesting vulnerabilities that have been found in audits, off the top of your head?
One vulnerability that is, well, already known by a lot of people, that was quite interesting. It was really, really simple, but in XCM, when you want to transfer, deposit an asset, you could fake, there was not something that limits the amount of assets that you will deposit. And the deposit instruction is normally the first one that you will put, withdraw an asset. So when you are executing an XCM, you need to withdraw asset in the other parachain to after pay for the fees and run the XCM and everything. The thing is that this first transaction is run before knowing if you can pay the asset, before knowing if you can actually pay for the XCM execution. And because there was no limit in the number of assets, you could put a huge amount of assets, and it will iterate trying to withdraw this and failing. But because you put all of this, after, if you don't have any asset at all, it will also have to run to this thing. So if you send a lot of this XCM, that you will technically spam the network. This is not an issue anymore, it was fixed. But this was like a huge issue, and it was fixed with just one line that just put a limit to the amount of assets that you can put in the XCM.
Hi. Can the fuzzing tools discover my my runtime's extrinsics and the inputs that it can take? I'm not really familiar with how fuzzing tools work.
Yeah, okay, sure. So normally a fuzzing, you will need to integrate it, let's say, it will create these kind of variables that are like anything. And after you will call a function with these variables that can be anything. And it will try to iterate in different ways. Normally it has a strategy, so it will not just put random things, it will try to go into a point where it will crash it. The good thing is that for Polkadot, there is this fuzzer. Let me show you here. Yeah. So there is this fuzzer. Yeah, I have it open here. That you can connect to your parachain runtime, and it will literally do this, and you don't have to configure it in every extrinsic that is available in your runtime. So every pallet that you have put in your runtime, it will try to execute it with different inputs to try to make your runtime crash. So feel free to go to this repository and have a quick look, and you will see more in detail how it works.
Thank you.
Yeah. All good? No more questions? Okay. Yes.
I think you read all the audit reports. What are the most common approaches, except manual audits, that external auditors are using? Maybe fuzzing, maybe, for example, formal specification or verification, because I've seen some companies there who are also doing some formal stuff. So that's the question.
What are the most common practices that
what
auditors
are the
do?
most common approaches to find some security vulnerabilities except manual audit?
Okay, so the right approach that, from my perspective, that auditors will take, but normally it's the most expensive approach because it will take more time, is executing a threat model before starting the audit. So a threat model, as I explained at the beginning, is more like a security documentation of your project. Why executing this is good at the beginning? Because in this way, the auditor will be able to see how things are moving inside and what are the things that are relevant and where are the points where it could fail. It will not find like the finding in that moment, but it will have a clear view of what are the weakness of this system. And with this in mind, now executing the audit, that is literally reading the code and testing with, it can be like fuzzing, or it can be integration testing, will be able to go directly to the points where it's dangerous and not waste time in the parts where probably will nothing happen. So combining these two things, fuzzers with like a good threat model, you can directly point, take your approach into the points that are dangerous, and in this way you can find quickly more high vulnerability issues. Okay. So this was the main questions. I will quickly go for the last steps. The last two steps are mainly designed for when you have like an incident, and is respond and recover. In respond, you need to define communication protocols and assign, that can help you to assign developers to fix something aside. So if you're launching a parachain, a solo chain, or any big production system that works 24/7, because blockchains never go down. Well, some blockchains they do, but Polkadot should never go down. And you need to define things like PagerDuty or SendDuty that will allow you to put developers in certain schedules that they will always have to carry their computer in their backpack. So if there is any issue, they will quickly go and fix it. You also need to define an incident response plan with playbooks and runtime versioning. This will allow you to prepare for like, a migration. In case an issue happens, you will need to quickly move to a new version. And you need to clearly define the mitigation strategies. Who is the people that will approve? So let's say you have a parachain, and there is an issue in your parachain. You need to quickly upgrade your parachain. You can use governance, or you can have a multi-sig. How you're going to execute this, you need to be clear even before launching your first version to production. Thanks to Polkadot, you can also have like governance and execute forkless upgrades. So you will not have to ask to all the nodes in your network to upgrade their node, because you can just execute it on-chain through governance. In the recover point, you have post-mortems that are documents that you can write about the incident that already happened. This is not mandatory, but it's a good thing to have, and it's a good signal to your ecosystem, to your community, because it will explain that what happened and how are you taking measures to avoid this happening again. You always need to have no backups. That is quite obvious. You need to have a recovery plan. So this means to have like good GitHub actions or automatization in general in your project. So if something happens, you don't have to be executing each step manually, and that could take maybe days, and you can just go quickly to production. Well, so this is a cycle, as you can see here. Once you understand this project, you will probably have to go back again to the beginning and try to improve this, and go again. And in each version, you will have to take this into consideration. Each one of these steps is kind of optional at your own risk, but you should take them seriously, and you should at least try to understand each one of these steps, so you are not taking a bad approach about security. Let me go back here. So well, the quick tour, if you want to go to, there is a better here. Polkadot Security Hub is here, you can access, it's online, and you can find all these resources here. I put also a blog where you can find the session, the Scali draw that I show, and the FAQ. Feel free to add more questions there if you want, or send it us by DM. And yeah, here you can access to the website, and I will also use this opportunity to mention that Parity is hiring, so if anyone has expertise in Rust, developer, and there is also like non-tech positions, feel free to go to this website. There is also application security, so if you want to be in my team, feel free to go here and postulate. We need some good security people, and thank you for coming to this session.
All right, thank you, Patricio. Doesn't look like many people are interested in security. Maybe the reason why we have had so many issues in our industry. Who knows?
Yeah.
But at least I know the people to follow now, hopefully for a resilient project. In about 20 minutes, we're going to have not a talk, but a workshop. And it's going to be about multi-chain indexers, exactly. So see you in about 20 minutes, and yeah, we'll see you again here.